Okay guys, so this is going to be free response set number 8. Okay, so it says consider a differentiable function and its derivative is given. Find the x-coordinate of the critical point of f. Justify if it's a relative max, min, or neither. Okay, so to find our critical points, we set f prime of x equal to 0 or where it's undefined. Okay, so we'll have a critical point at x is equal to 4. Set that equal to 0. We'll also have one at x is equal to 0. Now, it says that x is greater than 0, so we're not going to consider that one. Okay, that's it. Now, to justify whether it's a max, min, that sort of thing, going to make our little number line. And so I'm going to plug in like a 1. Okay, so 4 minus 1 is 3. 1 to the negative third power is 1. So this is going to be positive. If I plug in a 5, it comes out to be negative. So this is a max. Okay, so x is equal to 4 is a local max because f prime of x goes from positive to negative. Okay. Part B. This is find all the intervals in which the graph is concave down. Okay, concavity we get from the second derivative. So we're going to have a product rule. So we're going to write the first term. Derive the second term. It's negative 3x to the negative 4. Plus write the second term. Derive the first term. Okay. Now, once upon a time, I showed you how to factor stuff out with negative exponents. So whenever we factor this out, we're going to factor on x to the negative 4. Okay, when I factor that out, this becomes negative 3 times 4 minus x. And then if I factor out negative 4, x to the negative 4, leaves with a minus x. Okay, because 1 times a negative 4, x to the 1 times x to the negative 4 is x to the negative 3. You add the exponents. Okay, so we're going to distribute here. So we're going to get x to the negative 4th times 2x minus 12 is equal to 0. And so our possible inflection points are x is equal to 0 and x is equal to 6. Now we're not going to consider x is equal to 0 because our values are greater than 0. Okay, so inflection points occur where it changes concavity. So we're asking for where it's concave down. So we're going to plug in a 1. 2 minus 12 is a negative. Plug in a 7. You get 14 minus 12. It comes out to be a positive. So it's going to be concave down from 0 to 6. Okay. Because f, and if you want to, because f double prime of x is negative. Okay, you can never be too careful whenever you're doing these free response questions to how much words you add. Okay, now it says, given that f of 1 is equal to 2, determine the function f. Okay, so we're given the derivative, and I want to integrate it and solve for f. Okay, so the integral of 4 minus x over x cubed dx. Okay, so I rewrote this x to the negative 3. I dropped it down to the bottom. Now what I'm going to do is I'm going to split it up into 2 separate integrals. So this is 4x to the negative 3 minus x to the negative 2. And when I go to integrate that, I'm going to add 1 to the exponent, divide by the new exponent. Okay, so this is f of x is equal to that. And then to solve for c, we're going to use our initial condition. F of 1 is equal to 2. We're going to plug in a 1. So c comes out to be equal to 3. What we do is we take it and plug it back in there. So we get f of x is equal to negative 2 over x squared, if you want to write it that way, or x to the negative 2, plus 1 over x plus 3. That's my answer. Pretty easy question. Next one. It's a velocity and acceleration question. Okay, so said Ben rides his unicycle back and forth along a straight east-west track. The function b models Ben's position on the track, and it also models his velocity. Okay, and we're in meters and meters per second. Okay, so part A, it says I want to approximate Ben's acceleration at t is equal to 5. Okay, so a of 5 is equal to, so 5 is located in between these 2 points right here, 0 and 10. So you got to make sure you're paying attention to your velocity in this case. Okay, so it's going to be 2.3 minus 2.0 all over 10 minus 0. So it's 0.3 over 10. When I divide by 10, I just add an extra 0. So it's 0.3 meters per second squared. Okay, or meters per second. Either one's fine. Part B, it says using correct units, interpret the meaning of 0 to 60, absolute value v of t. Okay, so that's the total distance traveled. From t is equal to 0 to t is equal to 60. Okay. Now it says you want to use a left Riemann sum to interpret this. Okay, so your left Riemann sum, we got 10, 30, and 20. So this is going to be 10 times your, we need to be doing your velocity is what we're integrating. So 10 times 2 plus 30 times 2.3 plus 20 times 2.5. Okay, put that in your calculator, you get 139 meters. Part C, it says for 40 to 60, must there be a time where the velocity is equal to 2 meters per second? Justify your answer. Okay, so we're going to use mean value theorem on this. Remember when we say mean value theorem, it must be continuous and differentiable. Okay, so we're looking for velocity. So it's going to be your meters and is what we're going to be using for mean value theorem. So we're going to say b of 60 minus b of 40 all over 60 minus 40. So that's f prime of c is equal to that. Okay, so b of 60 is 49. B of 40 is 9. Okay, so that's 40 over 20, which is 2 meters per second. Therefore, mean value theorem guarantees at least 1c, where this is true. Okay. Part D, it says a light is directly above the western end of the track. Ben rides so that time t, the distance L between Ben and the light satisfies L of t squared is equal to 12 squared plus b of t squared. At what rate is the distance between Ben and the light changing at t is equal to 40 seconds? So we're looking for L prime of t, okay, or dl dt. So this is kind of a related rates question. So we're going to take our derivative. So let's write it. And if you didn't recognize, that's going to be a Pythagorean theorem kind of thing. Oh, sorry. Now, so we're going to take our derivative. So we get 2 L of t, L prime of t, or you can write dl dt. The derivative 144 is 0. And so we get that. The 2's will cancel. Okay, so we've got to figure what L of t is going to be. Okay, and we're evaluating it at 40. So L of 40 squared is equal to 12 squared is 144. B of 40 is 9. Like that. So L of 40, we'll put some parentheses around that, squared is equal to 225. 81 plus 144 is 225. So L of 40 comes out to be, the square root is 15. We're looking for L prime of t, B of t, so B of 40 is 9, and B prime of 40, okay, is 2.5. Okay, remember the derivative is going to be your velocity. Okay, solving for L prime of t, you should get 1.5 or 3/2 meters per second. Okay, I like this question just because it's something we haven't seen before. That's why I picked it. Pythagorean theorem over here. Make sure we get that right. We plugged into the original to get the L of t because we had the B of t. Okay, next question. Now I use this question. This question was on the continuity test, so that's why it might look familiar to some of you. We didn't do all parts in that section, but when I copied and pasted, this question was on the continuity test. Okay, so it says, is R continuous at t is equal to 5? Justify your work. Okay, steps of continuity. R of 5. Okay, R of 5, it's in this branch, it's equal to in this branch, so we're going to plug in. So 600 times 5 plus 5 plus 3 is 3,000 over 8. And if you want to simplify that, it comes out to be 375. Now, we also have to prove that the limit exists. So the limit as x approaches 5 from the left side of R of t, t approaches 5. From the left side, we already found that, is 375. As I approach from the right side. Okay, so if I approach from the right side, plug in a 5, we get 1,000 e to the -1 power, which comes up to be 367.879. Now, since your left-hand limit and your right-hand limit do not equal each other, the limit as x approaches, t, I keep messing up, t approaches 5 does not exist. Therefore, not continuous at t is equal to 5. Okay, so that's how we do part A. Part B, it says, find the average rate at which the water is draining from the tank from 0 to 8. Okay, this is going to be calculator. Yeah, so let me go ahead and write that calculator. Okay, so this is our rate, okay, our rate function up here. So if I want to find the average rate, I'm going to do 1 over b minus a. So it's 1/8 times. Now, we're broken down from 0 to 8. So we use this one from 0 to 5, and we use this one from 5 to 8 when we integrate. Okay, and we're going to use our calculator. So I'm going to put the first function in y1, and I'm going to use parentheses in my fraction. So math 9 vars y1, comma x, comma 0, comma 5. So I get that. So 123.4.5073. And then I'm going to put the other one in y2. So math 9 vars y2, and we're going to go from 5 to 8. So get 829.5 0.9146. Add those together and divide by 8. So you should get 258.052 liters, okay, per liters per hour. Okay. Part C, it says find R prime of 3. Okay, so R prime of 3. So 3 lives in the top branch up here. So I'm going to do math 8 vars y1, comma x, comma 3. So I get 50.000. Okay, and this is going to be liters per hour per hour. Okay, and it says using correct units, so I did that. Explain the meaning of the value. So the rate at which water is draining out of the tank is increasing at 50 liters per hour, or if you want to use liters per hour squared, that's fine. Says part D says write but do not solve an equation involving an integral to find the volume to find the time A when the amount of water in the tank is 900 liters. Okay, so we initially have 12,000 liters in our tank. And we're going to integrate to get the amount of water that flows out of the tank. Okay, so from 0 to A of R of t is equal to 9,000. Okay, so you want to find when you're going to have 9,000 liters. Remember that when you integrate a rate, you get an amount, okay? And we have this initial amount of water in our tank, so make sure we don't forget that. Oh, thank God, solid revolution. Okay, number 4. Okay, this is calculator. Okay, it says in the figure above, R is the shaded region in the first quadrant, and you have the graph y is equal to 4 natural log of 3 minus x. So it's that curve right there. Horizontal line y is equal to 6, and the vertical line x is equal to 2. Find the area of R. So area of R is going to go from 0 to 2. It's going to be top curve minus bottom curve. So it's going to be 6 minus 4 natural log of 3x dx. So we're going to put that in calculator. 6 minus 4 natural log of 3 minus x. Quit. Math 9 vars y1, comma x, comma 0, comma 2. So we get 6.8167. Part B. Find the volume of the solid generated about the line y is equal to 8. So y is equal to 8 is going to be up here. Okay, we draw our ladder. There's going to be white space. So we're going to have an R big and an R little. So R big is going to be top curve minus bottom curve. That's y is equal to 8. So it's going to be 8 minus 4 natural log of 3 minus x. And R little is the white space. So 8 minus 6 is 2, if you want to simplify that. Okay, volume is going to be pi times the integral from 0 to 2 of R big squared minus R little squared. Okay, now we're going to put that in a calculator. Make sure you, if this was on your AP test, make sure that you pay attention to if it says evaluate or not evaluate. This one says to evaluate. So we're going to do math 9 vars y1 squared minus y2 squared, comma x, comma 0, comma 2. And then we're going to multiply by pi. And so we get 168.1795. Okay, part C. The region R is the base for a solid for each cross-section is perpendicular to the x-axis, is a square. Find the volume of the solid. So volume is going to be the integral of the area. Area of a square is side squared. So it's going to be your top curve minus bottom curve. Like that. And we're just going to put that in a calculator and get an answer. 6 minus 4. We're going to square comma x, comma 0, comma 2. So we get 26.2666. Okay, that's it. Y'all should be really good at these problems by now. Okay, I like this question. Okay, it says the figure above shows an above ground swimming pool in the shape of a cylinder with a radius of 12 feet and a height of 4 feet. The pool contains 1,000 cubic feet of water at t is equal to 0. And you're going to be pumping the water out at a rate of P of t, which is given by this. Oh, sorry, in. This is going to be in. It's pumped into the tank. Okay. Water's leaking from the pool at this rate. Okay, so it's going to be removed. Okay, so part A, it says you want to use a midpoint Riemann sum, 3 subintervals to approximate how much is pumped into the pool. So 3 subintervals look like that. They're all equal to 4. Now midpoint Riemann sum, we always use the middle y value. Okay, so it's going to be 4 times 46 plus 4 times 57 plus 4 times 62. Okay, so you should get 660 cubic feet. And this is also a calculator question. Part B. It says calculate the total amount of water leaked out of the pool from 0 to 12. So you're given the rate and you want to know how much leaks out, so we integrate. So we put a RAT into y equals, so it's 25 e to the negative 0.05x. Math 9 vars y1 comma x comma 0 comma 12. And get 225.594 cubic feet. Okay, part C. Use the results from part A and B to approximate the volume of the water in the pool at t is equal to 12 hours. Round your answer to the nearest cubic foot. Okay, so we start with 1,000 cubic feet. We enter 660, and we take out 225.594. Okay, so when you put that in the calculator, you should get 1434.406 cubic feet. And we're rounding to the nearest cubic foot. That's all there is to it. Make sure you get that initial amount in there. Okay? Part D. Find the rate at which the volume of the water in the pool is increasing at t is equal to 8. Okay? How fast is the water level in the pool rising at t is equal to 8? indicate units of measure. So the volume of water in the pool is equal to the integral of P of t minus R of t. Okay? Now, if I want to know the rate at which that's changing, I'm going to take the derivative of it. So, it says I want to know how fast is the water level changing at t is equal to 8. So I'm going to plug in an 8 into both of these functions. Okay, so P of 8, we go to our table, is 60. And R of 8, you plug into that E function, and get 16.7588. 80, sorry, 80. Okay, subtract them, and you should get 43.2419 cubic feet per hour. Now, this combines everything we've learned and related rates. So we want to figure out how fast is the water level changing in the pool, so we're looking for dH dt. So V is equal to pi r squared H for a cylinder, and dV dt. We've got a product rule. Now, unless it specifies that the radius is going to be changing, which it doesn't in this case, that term goes to 0. Okay, we have dV dt is 43.2419. The radius of the pool is 12 feet. Okay, so we solve for dH dt. Okay, so we divide by pi, divide by 144, and we should get 0.0955. I don't know if I put this on a test or a review, but this problem's familiar. It's a good question. It deals with everything Riemann sums, it deals with accumulation and rates, related rates. So make sure you know how to do that. Okay, AB, this is gonna be your last question. In BC, we only got one more. Okay, a squirrel starts at building A and travels along a straight horizontal path from 0 to 18. Part A, it says, so this is your velocity function. So we automatically identify our critical points where it's going to change direction. So that's what we should do first. It says, at what time does the particle, the squirrel change answer, give reason for answer, okay? So changes direction. When V of t is equal to 0. Okay, so that's going to be at t is equal to 9 and t is equal to 15. Okay, at 9 it's going to go from positive to negative, and 15 it's going to go from negative to positive. Part B. At what time is the squirrel the furthest away from the building? How far from building A is the squirrel at this time? Okay, so what we're going to be doing is we're going to be looking for a displacement. So we're going to find the areas for each one. These are going to be trapezoids. If you want to use triangles and squares and all that good stuff, be my guest. Okay, so this is a trapezoid. So the integral from 0 to 9 of V of t dt gives you, okay, this is 9, 1/2. Your height is going to be 20, and 9 plus this base is going to be 5 long, 140. Okay. Same thing, area is equal to 1/2. The height is going to be 10. And this base is going to be 15 minus 9 is 6 and 4. So that's going to be 50. Okay, it's going to be negative 50 because below the x-axis. And then we got one here, another trapezoid. So area is equal to 1/2. The height is going to be 10. 2 and 3. 5, 50, 25. Okay, so VFT dt. So if we're looking for the integral from 0 to 15, it's going to be 140 minus 50, which is 90. Okay, and then if I look for the integral from 0 to 18 of VFT dt, I get 90 plus 25 is 115. Okay, so it's asking for what's the farthest position away from the building. So we're furthest away. At t is equal to 9. Okay, part C. It says find the total distance the squirrel travels during 0 to 18. Okay, so the total distance traveled is going to be the absolute value of the velocity function, the integral. So 140 plus 50 plus 25, and you should get 215. Okay, it says, part D, it says write an expression for the squirrel's acceleration, its velocity, and distance in between 7 and 10. So we're looking at this line segment right here. Okay, so we know that acceleration is going to be the slope of this line right here. Okay, so let's find that slope. Is going to be negative 10 minus 20 over 10 minus 7. So it's negative 30 over 3, which is equal to a negative 10. Do we have units? No units. Okay, velocity function. So the velocity of this portion right here is going to be the equation of this line. Okay, we already have the slope. Okay, and we have a point. So we can use the 720 or the 10, negative 10. So I'm going to use the 7 and the 20. So I'm going to say y minus 20 is equal to a negative 10 times x minus 7, the equation of the tangent line. And I'm going to solve for y. And then I'm just going to substitute a t for x. And I'm going to substitute this for y, VFT. And if I want to distribute, I distribute. So that's my velocity function. So it's a little tricky. We haven't done anything like this, so that's good. Now it says we want to find the position function at any time between 7 and 10. Okay, so I think the best way to do this is to integrate. So if we integrate this function right here, okay, we should get negative 5t squared plus 90t plus c. Now we have an initial condition. The position at 7 is 20. Yeah, this is a lot easier to do it this way than the way I did it earlier. So 7c. Okay, so solving for your c, 49 times 5, no clue what that is. 245. 630. Okay, 20 minus 40, oh wait, 20 plus 245 minus 630, and I get 365 for my, wait, did I mess up? Hold up. Did I type something wrong? 20, negative 245. Make sure I did that. 49 times 5. It's 245. 90 times 7. 630. Okay, it's 385. So 20 minus 385 is negative 365. I must have typed something in the wrong. Okay. And so my position function is going to be negative 5t squared plus 90t minus 365. I'm not give the same answer did here. I must have plugged it wrong whenever I did it earlier. Okay, so this is how we're going to do it. Still should come out to be the same exact thing. So, yeah, that's the position in that portion. I had to have wrote that down wrong. Okay. Next portion, number 7. Okay, so AB, you're done. BC, we're just going to do part A. So it says the Maclaurin series is given, and we want to find the interval of convergence for this thing. So when we do interval of convergence, we do a ratio test of A sub 1, n plus 1. Okay, so n minus 1 plus 1 is going to be n, and then we multiply by the reciprocal of the original thing. Okay, and then we're going to split it up. Two x to the n's cancel. Negative 1s don't matter because they're inside the absolute value. And I left off an n minus 1. So it's important to remember when we do ratio test that we're only taking the limit as n goes to infinity. So it's same power top and bottom, so it's going to be 1. So we're left with this. So when we do radius of convergence, it's always less than 1 for ratio test to converge. Now, I can pull the absolute value like that. So your radius of convergence is 1/2, if it asks. And we're actually looking for the interval of convergence. Okay, so when we do interval of convergence, we have to take each one and plug it into our original. So we're going to do 4 x is equal to a negative 1/2. Okay, negative 1/2 times 2 is going to be a negative 1. Add the exponents, negative 1 to the 2n power is just going to be 1. Negative 1 to any even power is going to be 1. Okay, so we have this. Now, we're going to use a comparison test, or you can use a limit comparison test. Either one will work. So your A sub n is 1 over n minus 1. Your B sub n is going to be 1 over n. Series B sub n diverges by P series test. Okay, now if we're using direct comparison test, we have to say that A sub n is greater than B sub n, greater than or equal to B sub n. n minus 1 is less than n, so that makes this function greater. Okay, the smaller the denominator, the greater the function. Okay, therefore, series of a sub n also diverges. Okay, for x is equal to positive 1/2. Okay, so we're going to plug in a positive 1/2 for x up here. So that's a 1. 1 to any power is 1. So we get an alternating series that looks like this. B sub n is equal to 1 over n minus 1. It's decreasing because it's bottom heavy. The limit as n goes to infinity of b sub n is equal to 0. Therefore, it converges by alternating series test. And make sure on your AP exam you write these test names out. So if we're talking about interval of convergence, it does not converge here, but it converges here. So we would write it like that. Okay, we are done with calculus for response number 8, and hopefully it wasn't too painful for you. If you have any questions, feel free to reach out, and have a good night. Thank you.